Okay, so we're starting a new chapter today. And this chapter is all about linear equations. And so we talk about the slope-intercept equation, which I believe you're all familiar with from pre-algebra. And then we introduce two additional equations, point slope and standard form. And so as we progress through the chapter, you'll be introduced to those. So this is the vocabulary that we're going to use for the chapter. We have a few more terms that we'll get to later. A Cartesian plane is just a coordinate grid like we have down here. Okay, and you'll be using these a lot this chapter for graphing. And so what we're going to do is, as we read through the vocab, we're going to mark up our graph at the bottom, which I believe you all know, but we're just going to do it anyway. So this first one is the x-axis, which is the horizontal line of the Cartesian plane. So right here, I want you to label this x-axis. Okay. And then when you're plotting an ordered pair, you always go along the x-axis first, which is either to the left or the right. It's actually the opposite of when you're trying to find the slope of something. The next vocab is y-axis, which is your vertical line right here. And so go ahead and label the y-axis. And then your quadrants are the regions of a Cartesian plane that are separated by two axes. So this quadrant is separated by the y-axis and the x-axis. That's kind of what that's talking about when it mentions the quadrants. So we're going to label our quadrants. This is quadrant 1. And you use Roman numerals. And then you have quadrant 2.
It's the other way. It is.
What?
It's the other way. It's 1, 2, 3, 4. Yeah, it's
Like
top left is 1, top right. Top right. Can you finish it?
Hold on a second. Are you sure?
Yeah. Yes.
Okay, my students just schooled me. So, okay. So this one here we go. It's quadrant 1. This is quadrant 2. Thank you, guys. This one right here is quadrant 3. And this one is quadrant 4. Okay. And then when we graph in quadrant 1, both your x and y of your ordered pair will be positive. When you graph in quadrant 2, your first number is negative, your second number is positive. Oh, no. When you graph in quadrant 3, both of your numbers are negative. And when you graph in quadrant 4, the first one is positive and the second one is negative. Okay, so, and then there's one last thing right here. This is called the, anyone? Origin. Okay. Now some of the terms that we did not cover, well, we know that the ordered pair is your x and y value on your graph. And when you graph a line and it is straight and the slope is the same throughout the line, that is a linear equation. And then your independent variable is your x value right here. And then the dependent variable is your y value. Okay. And that will become important when we start graphing real world problems. Okay, let's go ahead and go to page 2. So we're gonna be plotting points. Now, this, again, this whole page right here is a review. So what I want you to do is I want you to, I'm gonna have you plot all of these after I explain it a little bit. But remember, so for A, your origin is in the middle. Okay. That's at 0, 0. And you're always going to go either to the left or right first. So if it's positive, you go to the right. So I'm gonna go over to 3. And if your second one is positive, you're gonna go up. So you're gonna graph a point here. Okay, left goes to the left, and negative goes to the left and it goes down. So I'm gonna give you about 2 minutes to fill out this graph, and then we're gonna come back and check. So I'm gonna pause the video. Okay, so go ahead and check. Now, I want you to make sure your letters are correct. Okay. That will determine whether or not you graphed you on the negative side or the positive side correctly. And also, whenever you have zeros, those can sometimes be a little confusing. So if there is something that is not right on your graph, go ahead and change it. Any questions? Okay, let's go down to the bottom section. The bottom section, you are trying to locate the ordered pair and then write what your X and your Y value are. So for example, letter A is right here. So I do not move, remember you move left or right first. Since I don't move left or right, then it starts out as 0. But then I go up 3 on the Y axis. So I have 3. So wherever you move on the X axis, wherever you move to, that is your first part of your ordered pair because that represents the X. So I'll do one more with you and then I'm gonna have you do the rest. So for B, right here, I go along the X axis at 2. So my X is 2. And I go along the Y axis to -4. So it's -4. So your first one is always X, your second one is always Y. So I'm gonna pause the video and I'm gonna have you guys fill this out. I'll give you about 2 minutes to do so, and then we'll come back and check it. Okay, go ahead. Oh wait, I need to move it down. All right, go ahead and check your ordered pairs. Okay. And if you have any questions, let me know. Okay. All right, let's go ahead and go to page 3. So on these examples here, what it says, determine if each point is on the given line. Write yes if the point is on the line, write no if the point is not on the line. And what you're going to do is you're going to do this without graphing. And so anytime that we graph a line, there are ordered pairs that are directly on that line. And that's what this is asking. If I were to graph this line on a Cartesian plane, would 2, 5 land on that line? Or would the line go through 2, 5? Well, the way to figure that out is we know that 2 represents the X and 5 represents the Y. So you would plug 2 into the X and 5 into the Y, and it will look like this. 5 equals 2 plus 3. And you would solve it. You would simplify both sides. So in this case, 5 equals 2 plus 3, which is 5. And so because your left side equals your right side, then this ordered pair is a solution to the equation, meaning that the ordered pair will be on that line when you graph it. Okay. So we're gonna do that with each of these. This is your X, this is your Y. So we're gonna plug those in. So Y is -2. X is -5, and we're gonna add 3 to that. Okay. So -2 equals -5 plus 3 is a -2. -2 equals -2. So this is also a solution. Okay, all right, so go ahead and do the last one. So this is saying that 1 equals -1, and that is not the case. That slash through the equal sign means not equal. And so we will not circle C because -4, 1 would not be on the line. The line would not go through that ordered pair. Does that make sense?
So it's yeah, yes, now,
Uh-huh.
okay. That's it.
Okay. So now let's do, I want you to do example 2, but be careful, the equation's a little bit different. In this case, we take Y, which is 6, equals 2 in the equation times X, which is -1, and then subtract 4. Okay, so this equation's a little bit, has an extra step to it. So 6 equals 2 times -1 is -2 minus 4. 6 does not equal -6, so that is not a solution. Okay? So I want you to do B and C. And then we'll come back and check our answers. Okay, when you're ready, go ahead and check your answers. Okay, on your homework, when it asks you to do this, please show your work on these. I know that you're not gonna want to because you're gonna be able to easily plug it into the calculator, but I do want you to show your steps. That's important. Okay? Any questions on that? Okay, let's go down to our graphs. Right now, what we're going to do is we're going to graph a slope-intercept equation. Slope-intercept equations. So I want you to write this, slope-intercept. Is Y equals MX plus B, okay? Where your Y is isolated on one side of the equation, it could be reversed, it could be MX plus B equals Y. But this is typically how we write it, that's what you'll be most familiar with. If you see it reversed, you might get a little confused, but you can rewrite it. At least until you get familiar with all the different equations, so. The Y and the X, remember, those are an ordered pair. Just like what we did up here. Those are gonna be ordered pairs that the line will go through in your equation. But when we write it in slope intercept, we leave the Y and the X, just Y and X, we don't put numbers in there. But we do have numbers for M and B. M represents, anyone know? Slope. So that's your rise and run on a graph. And B represents the y-intercept where it crosses the y-axis. So in this case right here, 3 is going to represent your slope and 2 is going to represent your y-intercept. You always want to plot your y-intercept first. Okay, so in this case, our M is 3. And our B is 2. Okay. So always plot your y-intercept first, then graph your slope. So if my y-intercept is 2, I'm going to plot a point on the y-axis at 2. Then second, I'm going to graph my slope. My slope is 3. That means that I am going to rise 3 and run 1. So rise, run. So I'm gonna go up 3, 1, 2, 3, and over to the right 1, because it's a positive slope. That means it's gonna go up and to the left. Now, I'm gonna do that one more time. 1, 2, 3, and over, oops, sorry. 1, 2, 3, and over 1. Now, I do not think that most of you are used to this because you were always taught to go a certain direction. Now I'm going to show you, if you don't already know, that you don't only have to go up, you can also go down. So even though your slope is positive, you can go down. You've always been taught that in multiplication and division, two negatives make a positive. All right. So look, if I go in the negative direction down, 1, 2, 3, and I go into the negative direction over 1, I just, oops, 1, 2, 3, 1. I just created a positive 3 slope, because if I go down negative and over negative, two negatives make a positive. If I go up positive and to the right positive, then I also have a positive. So you could always go in both directions. How many points do you need to graph a straight line? 2. You just need 2. Now, I prefer more than 2. It gives me a more accurate straight line, but I know students typically do not do that, and that's okay. All you need are 2 points. But I need you to make those points known on your homework. Where are those 2 points? Because then that lets me know you know the slope. You always have to have a point on the y-intercept, and you always have to have another point that references a slope. If I can't identify your points, then I can't identify your slope. So make sure that those are prominent, okay? Let's do one more together, and then I'm gonna have you do I'm gonna do example 5 with you, and then I'm gonna have you do example 4 and 6 on your own. So let's go down to example 5. Our slope is a negative 1/3. And our y-intercept is a positive 4. So again, we're gonna plot a point on our y-intercept, then we're gonna graph our slope. So it's a positive 4. I'm gonna plot a point at the positive 4 on the y-axis. Now, one thing I need to make clear, our slope is a negative 1/3. That means I'm going to rise up 1 unit and run over 3 units. Let me show you what some people do. Is that they'll go up a third. I'm gonna use my pencil so I can erase it. They'll go up a third of a box and over 1. Okay, I've seen that happen every year. And you may be one of those, so that's why I want to clarify it. Instead of doing that, I want you to go up one box and over to the left 3, 1, 2, 3, because we're making our slope is negative, so we have to make a negative slope. And so when I showed you that, I should have made it here. Do not just go up a third of a box, okay?
So you don't go down.
You could go down 1 and over 3 here, this way. You could go either direction.
But when it says negative, doesn't that mean that both of them are negative? 1 and 3?
No, that means that, and I'm glad you asked that question. Remember, 2 negatives and 2 positives make a positive. But a negative and a positive make a negative, right? So that means you go one direction that's negative and one direction that's positive. And it doesn't matter which one is negative and which one is positive. So if I go up, that's positive, right? Because up the number line is positive. If I go to the left, that's in the negative direction on my number line right here. That gives you a negative. So if I have one positive direction and one negative direction, that gives me a negative slope. I could also go down towards the negative end, that's negative, but then I'd have to go to the right, which is in the positive direction, and a negative direction, and then a positive direction equal a negative slope. Does that make sense?
Yep.
Okay, so now let's draw our line. One other thing, when you draw a line on a normal just an equation graph, you draw your line and then arrows go at both ends. If you miss your arrows, what you're saying is that the line does not continue in both directions infinitely. So that would make your graph line incorrect. So make sure you have arrows at both ends. Okay, I want you to go ahead and graph examples 4 and 6 on your own, and you can work with a partner to do that, or at least check your answers with a partner, and then we'll come back and check them. And I'm gonna pause the video. Okay, go ahead and make sure your lines are graphed correctly. Oh, yes, okay. I was like, I thought I messed up one of my slopes, but I did.
Oh, we did not, we did this.
No, it's good.
You rise for each one. For this.
Okay, is there a, oh, okay. All right. So questions, comments, concerns? Okay, let's go to page 4. And this is probably the new part. And what this is you're taking word problems, you're creating a table and an equation and a graph. And I'm very particular about my graphs. So make sure that when you're doing your homework, that you include all the parts of the graph, and we'll go over that in a minute. All right, so here we go. The perimeter of an equilateral triangle equals 3 times the length of its side. Now, these word problems, we've created equations from before. So we know that perimeter is P, they tell us that. And it's of an equilateral triangle equals, so we're just gonna make an equal sign. 3 times, that just means 3 times the length of the side, okay? That is our equation. This is not new, but we are gonna practice it some more. So I'm gonna rewrite this equation right here. P equals 3S. Now, I don't like to use S's, but in this case, we are. I could have used L. Okay, so now I want to ask you a question. This is a slope-intercept equation. We're just not using y and x. So if my slope-intercept equation is y equals mx plus b, right?
Must be,
What was that?
do you think the plus be like not? It's not necessary. Right? It's not necessary.
No, right. So if you don't see a B, that does not mean there's not a y-intercept. There is a y-intercept. It's just a 0. So the y-intercept for this would be 0. What's our slope? Huh? 3/1. It's 3, right? So then which letter represents our x and which letter represents our y?
S.
S is x and P is y. So we're going to create a table of values. So I have x here, which is S. And I have y, which represents P. Now, let me tell you why I like to use different letters other than x and y when we're dealing with real world problems. It's because when I get down to the end, I want to understand which variable is represented by the perimeter and or what the perimeter is represented by which variable and what the side lengths are represented by. Okay, so now what we're gonna do is we're gonna say, okay, if the side length equals, now it can't equal 0 because if we had a 0, then we wouldn't have a triangle, right? So what if my side lengths equals 1? And they don't give us the unit, it's 1 unit, right? We would plug 1 into the equation for S. Okay, so this would be P equals 3 times 1, which equals 3. So then P equals 3. Okay, so you're just creating a table like this. Can we have negative numbers for the x values? Anyone? Can we have negative values in this column?
Yes.
Okay, so then that would be saying that our sides can be negative units. So if I were to measure my triangle, can I measure my triangle and say, okay, this is -3 inches?
No.
No. So anytime you're dealing with typically when you're dealing with money, although if you don't handle your finances right, you might be in the negative. But units and money will typically all be positive. When you're selling something like tickets, those will always be positive. You can't sell a negative ticket, right? So think about that when you're creating your table. So I'm gonna plot 5 points. 1, 2, 3, 4, 5. And what this table is saying is that if my side length is 2 units, 3 units, 4 units, and 5 units, what would the total perimeter of my triangle be? So again, you're just plugging in the S into your equation and you're getting your perimeter. Okay, and perimeter 3 times 5 equals 15. So 6, 9, 12, and 15. So what is this table telling us? If you were to explain just the table, can somebody tell me how to explain the table? They are order pairs on a line for sure. And it's saying that as the side lengths increase by 1, the perimeter is increasing by 3. Okay. So let's write that down here. As side lengths increase by 1 unit, the perimeter increases by 3 units. Okay. Now we're going to graph this. Now it just so happens that we have enough space on our graph to make increments of 1. But let me show you something. Whenever we use a graph, we want to try to use up as much of the graph as we possibly can, okay? So if I look at my x-axis right here, what is on my x-axis? Is it my side length or my perimeter? Okay, so look right here though. We have y right here, which is perimeter, and x right here, which is side length. So yeah, it's going to be the side length. So side length here. Okay. And then my perimeter would be on my y-axis. And then I need to give my graph a title. All graphs need to have a title. So I'm just gonna name it. Okay, now a lot of students ask me, what does my title need to be? Your title can be anything related to the problem. Okay. We wouldn't name this circles. It doesn't have anything to do, circles have nothing to do with this problem, but triangles could be fine. So now we've labeled our graph, the x-axis, the y-axis, and the title. Now we're going to do our increments. It's important that you use reasonable increments. So I'm going to start at 0. Your graph always starts at 0. And then I'm going to go by halves. So I'm going to skip a line and put 1, skip a line, 2, 3, 4, and 5. Because my exit values go up to 5, I have to at least go up to 5. Okay. Now you don't have to skip lines. So for example, on my perimeter, I go all the way up to 15. And I happen to know that there are 15 boxes right here. So I'm just going to go by 1s, but this time I cannot skip a line. So 1. And you're going to put your increments all the way to the top. And now there's two ways you can graph. You can graph your equation or you can graph your table. All right, so let's go ahead and you can graph it either way. I am going to graph my table. So 1, 3, 2, 6, 3, 9, 4, 12, and 5, 15. Now, in this case, it's a real world problem. So when you graph your line, you will not have a, oh, and what is our y-intercept in our equation? Our slope is 3. Our y-intercept is? It's the origin. That's right. It's at 0. So you will not have an arrow here because then that would mean that it's going to go in the negative direction. And remember, units cannot be negative. So we can though, and need to have an arrow going in the other direction. So we have our equation here, which was part of our answer, our table, and our graph. So just to reiterate, your graph needs to have a title. It needs to have a label on the x-axis and the y-axis. It needs to have reasonable increments, and then it needs to have your line correctly drawn with the plotted points. Okay. Okay, let's go down to the bottom. I'm going to do this one together, and then I'm going to have you do 2 on your own. So it says the number of yards y is equal to the number of feet f divided by 3. All right, so we're just going to write it as we read it. The number of yards y is equal to the number of feet divided by 3. Okay. So that's our equation, and now I'm just going to write it. Yeah, we don't remember in algebra, we don't use the division sign. So y equals f divided by 3. And this is our equation. And now we are going to create a table. So remember, we have x and y. What is the x in this equation? F, and the y is y for yards. Okay, this time I do not want to use 0, 1, or 2 because I want to use numbers that are easy to graph. Numbers that are easy to graph are whole numbers. So what is a number, the first number that you can think of that when you divide it by 3 will give us a whole number? 6, 9, there's one lower than both of those? 3. So I'm going to go by increments of 3. So I'm going to do 3, 6, 9, 12, and 15. Almost the opposite of what our equilateral triangle was. Okay. Now, if 3 were plugged into our equation, we have y equals 3 divided by 3. That gives us 1. So our y is 1. 6 divided by 3 gives us 2, and so on. So go ahead and finish your table. Now we need to come up with a title. So I'm just going to label it feet to yards. Now I want you to label the X and the Y axis, and then I want you to check with your partner to see if you guys labeled it the same way. Okay. And then check up here to see if you got it right. Oh, yes, I'm sorry. Okay, so can someone tell me what increments should we go by on the x-axis? On the x-axis, yes, we go by ones and we don't skip a line. So we start at 0, your origin is always 0, don't start your 1 right there. And go ahead and write your increments. And then on the y-axis, I'm gonna go by halves, so I'm gonna skip a line for each one. Okay. And then I want you to go ahead and graph your table. And check up here to make sure your graph matches. Any questions? All right, let's look at the next one to see if. Finish this. Let's go ahead and go to page 5 and see if this is something. Okay. This is what I want you to do for this one, and then we're gonna do number 10 together. That one can be a little bit tricky. So on number 9, I want you to come up with the equation, your table, and I want you to label your graph. And then before you plot your points, we're gonna check together just to make sure all of that is okay. All right, so I'm gonna give you about 3 minutes to do that. So go ahead and work with your partners or on your own to complete that. Okay, I want you to go ahead and check your equation first before you do a table, because if your equation's wrong, your table will be wrong. So are there any questions about the equation? Okay, go ahead and work on your table next. And I'm going to pause the video. Okay, go ahead and check your table. Any questions on that? All right, I'm going to pause the video and I want you guys to label your graph. Okay, check your graph to make sure that it was set up correctly. And then you're going to plot your points. Now, you might have used different numbers. Maybe you started at 0. You can have no profit. Whenever you're dealing with profit and losses, you can have a loss. So if they didn't make any money, if they didn't sell anything, but they put out money and they never got that back, then that's a lack of profit. All right. So you could have started, but then that would mean that our graph would have to go down to the negatives, and I didn't do that. So. And you could actually keep going if you wanted to on the graph. So on your graph, you don't have to skip lines either. I just like to do that to use up all of my space. Okay, any questions on this one? Okay, let's go to the next one. It says the cost C of producing X units is 2,000 plus $1 per unit. So let's look at this. The cost C of producing X units is $2,000 plus $1 per unit, and they're telling us that the unit is X. And per means to multiply those two together, okay? So I want to write my equation in slope-intercept form, but the way that it's written here is C equals 2,000 plus 1x. Okay? But again, I like to have my equations in slope-intercept form, so I'm gonna rearrange this to be c equals 1x plus 2,000. In slope-intercept equations, though, when your slope is 1, you don't have to write the 1. You can, but you don't have to. One other thing that I want you to be aware of is that when you have units in a problem, such as the dollar sign, don't include that in your equation. You only include that in your final answer. Okay, so this is the equation that we're going to use. All right, and so now we're going to create our table. Our X is just X, but our Y is represented by cost, so that's C. And our units, we can go by ones on our units, so let's go ahead and do that. Actually, I'm gonna start at 0, so if they sell no units, then you get 2,000. And then I'm gonna go all the way up to 5 units. Okay, so go ahead and finish filling out the table. And this is what you should have gotten. And this is gonna be different to graph. I'm gonna show you what to do in a graph when your numbers are really large. Right now, though, I want you to label everything on your graph. And then I want to make sure you label it correctly, and we'll come back and check it and then graph. Okay, so here's how I set up my table. Again, your title could be different. This is number of units and total cost. But because we start at 2,000 and our graph is not 2,000 units long, we could go by different increments. We can always go by, I don't even think we could go by hundreds, like 200s we could go by, but the thing is if you go by 200s, well, I don't even know if you could go by 200s. Or you go by 500s, these are kind of so close together as big numbers that I'm gonna create something called a break in the graph. That means that there is gonna be a gap between the origin and your first number. Okay, and you typically cannot do that. So like you wouldn't go from 0 to 8 and then go up by ones. Because that's not a proper graph unless you create a break in the graph. And this is what a break looks like. Okay, you start in the corner of your box and you do this little triangle thing. And then it almost looks like something on one of those heart monitors. Okay, but that is just a break. That's telling me there's going to be a gap between my origin and the first number. And then what I'm going to do is I'm going to start at 2001 and skip a line and go to 2002 and then 2003 and so on. Okay, and now I can graph my table. Oh, I should have started at 2000, huh? That's all wrong. Whoops. We all make mistakes. Please forgive me.
What is the sign? Like,
It's like a little sideways channel.
Yeah.
It bases the lines.
Okay, now I can graph accurately. So I'm gonna start here. 1 to 2001. 2002. And then we can draw our line. Okay, any questions? All right, that concludes lesson 3.1.